In this video, we'll define secant lines and average rates of change. This will be a pretty short video. We're just going to define a couple things and be done with it. So let's just dive right in. Let's say we have a graph, and we're graphing a polynomial. Let's say it turns out it's a cubic. And the idea is, I want to know about, okay, on average, what's the rate of change between these two blue points? Well, if we think about rate of change, that really only applies to linear functions. And the idea is, on average, I can just find the slope. So the change in x and the change in y between those two. Once I calculate that slope, then I have my average rate of change. So average rate of change, I'll abbreviate it here, is going to equal your change in y over your change in x. Now you may notice on this red curve it dipped way down, but then spiked way back up. So just saying, on average, if every time during the x as I'm going over, I went up the same amount of y, how big would that be? Now you might not find that very helpful, but that is what average rate of change is, and sometimes it can be useful for thinking about things. Now, we see this all the time without really realizing it. We talk about our average speed, usually when we're driving, we're going somewhere. If, say, I drive 60 miles in 60 minutes, well, I didn't necessarily go 60 miles an hour the whole time. There were probably some points where I was going a little faster, and there were probably some points where I was going a little slower. But on average, I can say, yeah, I was going 60 miles an hour. Now this line, this blue line here, is called a secant line. And that may sound familiar as a trigonometric term, secant being 1 over the cosine. So a secant line, kind of like a tangent line, so a tangent line intersects a curve or a circle at one point. A secant line intersects at 2. And that is what a secant line is. And it's very useful if you're talking about slope of a secant line. That's your average rate of change.